Let's review multiplication. There are 3 things I'd like for you to take away from this video. The first is that there are many ways to multiply, and whichever way works best for you in any given situation is the one that you should use, always. They are all going to get you the same answer. But the second thing I want you to remember is that it's important that you know how to use most or all of these strategies, because what you're going to find is that different kinds of multiplication problems may best be solved using a different one than you might be more used to. The third thing that I want you to remember is that when we're doing a multiplication problem, the order of the numbers that you're multiplying together does not matter. So for example, 3 times 6 is the same as 6 times 3. This is not true for all operations. This is not true for subtraction or for division, but it is true for addition and multiplication, both of which you're going to see here. So an algorithm is going to be your traditional method of solving any operation. In this case, because we're dealing with such small numbers, it's really just going to be memorization. So 3 times 6. Well, I memorized my 3's times table, so I know that 3 times 6 is 18. And I memorized my 6's times table, so I know that 6 times 3 is 18. Coincidence? I think not. An array is going to be a drawing of a box that is split into 3 sections one way and 6 sections the other way. So I'll show you what I mean. 1, 2, 3, 4, 5, 6 sections vertically, and you don't have to follow the lines on a piece of notebook paper. I just find it easier to do it that way. That's 6 sections vertically and 6 sections horizontally and 3 sections vertically. So you can see what we're looking at here is 3, 1, 2, 3, 4, 5, 6 times. 3 times 6 is 18. But I could do the same thing by doing it 6 times 3. 3 sections vertically and 6 sections horizontally. Or I think I said it backwards again. 3 sections horizontally and 6 sections vertically. So that's 6 times 3. See, it's 6 right there. 1, 2, 3, 4, 5, 6. 3 times. 1, 2, 3. 3 6s is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you see we get the same answer both times. Equal groups is going to be pretty much the same concept. I'm going to draw either 6 equal groups of 3 or 3 equal groups of 6. And you'll see that I get the same answer either way. So here's 6 groups. And as I said, it's 6 equal groups of 3, so each one will have 3 in it. And it's called equal groups because they all have the same number. If I now count up my tallies, I will find that I get the same answer as when I did the algorithm or the array. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 3, 6 times 1, 2, 3, 4, 5, 6 3s is 18. I also could have done that as 6 3 times. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And I'll get the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 6 times 3 equals 18. Now let's try repeated addition. This is where we're going to just add on 3 every time until we have 6 3s. So that's 3 once, 3 twice, 3 3 times, 3 4 times, 3 5 times, 3 6 times. 3 times 6. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15, plus 3 is 18. Or I could do 6 3 times. 6 1 time, 6 2 times, 6 3 times, add them all up. 6 plus 6 is 12, plus 6 is 18. So you see I continue to get the same answer every time. Skip counting is something that I can do mostly in my head. If I'm going to skip count, that means I've pretty much memorized my threes times tables, just maybe without the knowing what I'm multiplying it by. That is, I can say threes would be 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, and so on. So in this case, what I want to make sure is that I'm skip counting 6 times. So I'm going to go ahead and just make 6 marks to help me count. So that's 3, 6, 9, 12, 15, 18. 3 times 6 equals 18. Or I could do it with sixes. So 1, 2, 3 sixes. 6, 12, 18. 6 times 3 is 18. And I can also do that with my fingers. I can hold up 6 fingers and count by threes to count by threes 6 times. So that's 3, 6, 9, 12, 15, 18. And I know that I have counted up 6 threes. So that's 3, 6 times, 3 times 6 is 18. And then counting on is going to be the same concept as with repeated addition and skip counting, except I'm going to have a little bit of an aid to help me add those up. So if I'm doing threes, I'm going to draw myself 3 counters to help me count up. So every time I add 3, I'm going to count it on here. So I start with just 1 3. And I know that that's 1, 2, 3. 2 threes would be the same, but with another 3. So 3, 4, 5, 6. Now I add another 3. 6, 7, 8, 9. Now I add another 3. 9, 10, 11, 12. Now I add another 3. 12, 13, 14, 15. And now I add another 3. 15, 16, 17, 18. So you see, every single time I've gotten the same answer. 18, 18, 18, 18, 18, 18, 18, 18, 18, 18, 18. So if you were doubting whether 3 times 6 is 18 or whether 6 times 3 is 18, I hope you are not doubting me now. But while I said it, I did say, and I truly mean, that every single one of these methods is great, and whatever works for you is the one you should use. I do want to show you why it's important to have more than one in your tool belt. Let's try something larger, like 3 times 58. Which we know that the same rule is going to apply here. 3 times 6 is 6 times 3. 3 times 58 is 58 times 3. Well, I don't know about you, but I don't particularly want to make an array that involves 58 sections. That's going to take up a lot of my time. I don't really feel like doing it that way. Equal groups, I don't really see myself making 58 equal groups. I don't even see myself making 3 equal groups of 58. That's a lot of tallies. So these two are pretty much out for me. I don't think that they're really the kind of thing I'm looking for. Counting on is going to take a long time, especially if I'm doing a method like this. I don't want to draw 58 counters, and I don't really see myself counting 1, 2, 3, 58 times. So that one's pretty much out too. But you'll see that we'll come back to some of these. Skip counting, I can't really see myself skip counting by 3 is 58 times. And I don't know how to skip count by 58s because I definitely never thought I'd need to be able to do that. Let's try repeated addition. So I don't know about you, but I don't want to add up 3 plus 3 plus 3 plus 3 58 times. But I don't mind adding 58 3 times. So 58 plus 58 plus 58. 8 plus 8 plus 8. Now, if you're having any trouble with that, use your fingers or use that counting on method. 1, 2, 3, 4, 5, 6, 7, 8. 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's 16, 17, 18, 19, 20, 21, 22, 23, 24. And then because that 20, of course, belongs in the tens place, I'm going to carry my 2. Now I've got 2 plus 5 plus 5 plus 5. Of course, it's in the tens place, so really that's 20 plus 50 plus 50 plus 50, but it's going to be easier to consider it just 2 plus 5 plus 5 plus 5. So that's what we'll do for now. 2 plus 5 is 7, plus 5 is 12, plus 5 is 17. So my answer is 174. And you can see that because it goes in front of that 4, it's automatically going to be put in the tens place, so we don't have to worry about that. 174. That's the answer that we got. Now let's try it with the algorithm, and you'll see that you're going to get the exact same answer. The algorithm, 58 times 3. First, I need to do 8 times 3. Well, if I'm having a hard time remembering that, just like I might have had a hard time remembering 6 times 3, I can use one of these options again. I'm going to go with array, but if equal groups is what you prefer, you could definitely do that as well. So I'm going to do like this, and you'll see this time I'm not even using the lines as a guide because I'm trying to make it kind of small. But if you have graph paper, you might find this easier. So that's 1, 2, 3, 4, 5, 6, 7, 8 times 3 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 8 times 3 equals 24. So I put the 4, because that's in the ones place, right there. And because the 2 is in the tens place, I need to hold on to it. And once I figure out what's in my tens place, I can add it into there. So I'm going to put it up here in the tens place for now. 5 times 3 is 15. So I know that in my tens place, I'm going to have a 15, which really is 150 because it's in the tens place. But now I need to add that 20 back in there. So 150 plus 20 would be 170. So it's 174. And so you see, I get the same answer. So perhaps you see here how it's definitely going to be easier to use some strategies in different places than others. Whatever works best for you is definitely what you should use, but be familiar with all of them so that you can use them anytime you need. And always remember that when you're multiplying two numbers, it doesn't matter what order the numbers are in. And I think that will help you be able to choose the best method for multiplying that's going to work best for you. All right, I hope that helps.